Another 2 minutes, we'll start.
Sir. Sir.
Yes, tell me.
Sir, can you once again explain how the fork sends different values to different processes?
Different values to different processes. Which one you are saying?
So that fork, sir, like the parent process will get the child process ID and child process will get 0, sir. How that happens, sir?
Oh, that is actually fork's rule is that since fork will be first executed, then the assignment will be done. The fork returns two values to the two things. One is who has created the fork, means who has called the fork. To him, he is returned back the child process's ID. And newly the process which is created by the fork, to him it is returning 0.
Sir, so the fork will be executed in both the programs?
No, fork will be executed by one program, but the return will be done to the two programs, you can say. Because if the fork will be executed by two programs, if you can say, then there is a 3 processes will be created. Am I correct or not?
Yes, sir.
But it is only creating one process, means fork is executed by one process. But that fork is returning two kinds of value. One value is returning to the new created process, and one value is returning to the process who has created a new process. And who has created this new process, to him he is returning the child process's ID. And the process which is created now, to him it is returning the 0. The reason is that the process which is currently created, he has a function called as a get BPID to remember it. Why he has a function? Because in every process's process control block, parent process ID is there. But there is no provision. Last class the PCB, the OS, when it is creating a structure for each process, he never keeps who are the child of a process. Only he keeps who is the parent of a process. Okay or not? I'll give one example now. I'll give one example so that you will be more clear. No problem. Not an issue. You will understand. So I'm starting now. Just within a minute. I'm starting. Yes. So what basically happens, once again I'm clearing your doubt, because when this is my main program, so if I make a fork here, then who has executed this line? The first process P1 was already created. Why it is already created? Because this program you running by a ./a.out. The moment you run this ./a.out, for this one process gets created. This is my P1. The P1 is executing this line. So if it is executing this line, means he is creating one process called as a P2. But the moment this process created, then this part gets assigned. Then how it will be assigned? He is saying, if the process ID of a P1 is 20, if process ID of a P2 is 45, then he is saying Here T will be assigned with what? Tell me. 45. And here T will be assigned with G. Because it will be written two values to two different processes. So after these things, the T for this and T for this is different. Since both becomes different, you can distinguishing by if T is something, what to do, else what to do. Okay, T is returning like this. You can go through one file. You can do this. I'll clearly show you also. Whether currently I have not gone through that. Okay, later I'll show you that. In there is a proc.c file is there in x86. There you can find the fork implementation. There you can find that how it is returning 0 to this and this to this. I'll show you once. Okay, the file name is called as the proc.c. There you can find a function called as fork. Inside this you can know the
in the tree of the Linux.
In the
Linux tree. वहाँ मिलेगा ये वाला.
No. यहाँ पे आपका है.
सिस्टम में.
नहीं सिस्टम नहीं में एक्चुअली टाइम नहीं मिल रहा है. आपको भेजना चाहिए था मुझे एक्चुअली. This is where it is. Mars. Where I kept. Sorry. तुरंत बताता हूँ. एक मिनट मुझे. Here if you make properties. If you can go to this, if you can little go through this, you can know about if it's not able to create any process, then it will do like this. And what you have studied, the all process states will be copied from one process to the child process. So he is doing it here. Okay. And return value, you can look into it how it is returning the 0 to its child process and the PID of the parent process to whom. Okay, child process का कैसे वो जो variable होगा, whatever it is returning, how it is returning child process that one and how he is returning here just. Okay, just 1 minute, just see. So when a new process created, now he has setting the EX register. From the EX register, it will get the return value. And for the old process who has created it, he return itself the child process's ID. That's why the two things get set at a time. As per this. Quick.
Sir, at the end of the day, sir, ये सब तो एक क्या बोलते हैं पेज है ना, मतलब वर्चुअल मेमोरी है. तो क्या सर जब हम कोई प्रोसेस को और एक प्रोसेस बनाते हैं तो वो भी एक मैलॉक से होता है क्या?
नहीं, मेमोरी जब एलोकेट करते हैं उस टाइम पे तो मैं मालक जैसा लिखूंगा. जब मेमोरी उसके लिए एलोकेट करूंगा तो मालक जैसा लिखूंगा. Okay.
Yes, sir.
Okay. So you just go through once this proc.c xb6 you can search. You can clearly understand that how it is happening, and I have also shown you here how it is returning two things. In one part he is returning 0 to the child process. In another part he is directly returning PID of the child process. So PID of the child process will be returned back to whom? To this fellow, and 0 will be returned back to this. So by this way it is happening. Okay. So last class we stop at one point that I discussed, that when n number of childs are created, all the childs along with the parent are executed simultaneously. Since they are executed simultaneously, we cannot predict that which one will be executed first. So it may happen the parent has created the child, but before the child gets terminated, the parents get somebody's mic is on. Could you please just mute it whenever required? You can do it. Huh? Fine. Okay, now it's stopped. Thank you. No, still. Okay, I'm muting. No problem. You may not have present. Okay. So that's why what you did. since my printf will be executed for all, but this printf is basically says that it will be executed as per this figure by 4 processes, P1, P2, P3, P4. Since P1, P2, P3, P4 will be execute this print statement in any sequence, it may happens that this process, the parent process, will be first executed, then the P2, P3, P4 will be executing this one. If it is happening, then what happens? After the P1 executing this printf, if the wait is not there, then it is terminated. Once it is terminated, his ID will be removed from the process table. If it is removed, then what happens? This P2, P3 and P4's parent ID will be become who? Who is the parent of this? And they are called as basically the orphan processes. And orphan processes of parent कौन होता है? कल बोला था. Who is the parent of? That is init. Init will be automatically taken care of this. So in this way, it is happening. But somebody has immediately asked, sir, whatever the job you have told just before some time, suppose I have a 2 into 3 plus 2 by 3 plus 2 to the power 3. If I am assigning 2 into 3, 2 by 3 and 2 to the power 3 to these 3 childs, and after he is getting a result, then he will make a summation. But if this process will be fast finished and they have not complete their work, then whatever the result comes, that is useless. That's why what they are saying, why don't this process has to be wait until this child will get terminated? So for that, there is a function called as a wait. And what the wait says, the wait function is a system call which will wait for a child to be terminated. Okay, so how it has to be written? It can be written in simply in this manner. Suppose I have created many childs, so int main, clearly I am writing so that without any error you can just copy paste in the code and execute it. So I have created a for loop. I created I0, I less than 3 processes, I plus plus, and I created t equal to a variable आप लोग declare करोगे, हाँ मैं नहीं लिखता हूँ आप लोग करोगे, t equal to this fork, and once the fork gets created, if my child means t is equal to 0, I am making break. The moment I am making break, so all the childs are not again iterated, rather the parent gets iterated. If the parent becomes iterated, then after that what I do, I am doing this printf statement. So printf something I am doing. So ABC doing this thing, or I'll make a %d, then get PID and get PPID. That get PPID. So when you are doing these things, what you do, if you don't wait, then the parent process may be terminated. So we can make a wait. So how we can wait? Wait. Here you have to pass either null or this. How the wait will be written? Int wait int star. This is the declaration of the wait function. Means what it is? He takes a pointer and returns an integer. What is this pointer? The pointer says that he is waiting for the child. When the child gets terminated, always a process gets terminated by returning some value. So either he has to be return 0, or you are sometimes writing by a exit something. Yes or no? Exit something. So the way it will be written now, that return value comes here. And whichever the process is currently terminated, that PID will become here. So this is the PID of terminated process, terminated child, and this is basically what way the child has terminated. What way the child has terminated. Yes. So what you do? 1 minute. You can ask me. Okay. So S, I'll make it. I'll make %s. I can make here a int k. So by this k, I can know which child has terminated. But here there is a issue. What is the issue? The issue is the wait basically says that I am waiting for only one child to be terminated. He never says that I am waiting for all the childs. So since he is waiting for one child only, so since we have created 3 childs, if this child he is waiting, once it is terminated, even if these 2 are not terminated, still he is going to be dead. So what you want? You don't want this. What you want? You have to wait for all the childs. Since you have to wait for all the childs, instead of writing this code, can you write a while loop or not? while this wait, yes, you can pass and all if you don't want to take the value कैसे मरा है, अगर नहीं चाहते हो ऐसे कर दीजिए, and you make a d. D is returning if it is not equal to -1 or not equal to -1, then it will continue. So what happens here? What happens here? If it is returning a positive value, means one process gets terminated. If it is one more, one process gets terminated. When all the process gets terminated, this wait function returns a negative value. So if it is returning a negative value, then immediately you can say all process gets terminated. So instead of writing this, we have to prefer this when if a process has multiple childs. If a process has only one child, this is sufficient. If you have a multiple child, maintain a while by which you can do it. Okay, so this is basically called as a wait system. Okay. Now the next one comes, that is another interesting part, very, very important part, that suppose I am writing a code, please look into it. Int main, and then I've written a t equal to fork, and I've written if t not equal to 0 or greater than 0, better to write greater than 0. T is greater than 0 means it is a parent process. If it is becoming a parent process, what I did here, I declare int k and I make a scanf something. Scanf %d and k. And in case of this else part, I have wrote here simply printf ABC. Yes, and then I close this. Can anybody quickly tell me which process will be first terminated in this case? Because here the P1 creates a P2 child. If P1 creates become P2 child, this part is belongs to whom? P1. This part is belongs to whom? P2. Am I correct or not? Can anybody tell me which part will be executed first?
Sir, P2.
P2. Very nice. Because it is a simple printf statement, but it is a block statement. Block statement IO. It is also IO. This is also IO. This is also IO. But in this case, it is blocked. He is waiting. The user has to enter a value. But in this case, you will directly send it to the buffer and tell them my work is over. Yes. Since this child gets terminated, but during the child gets terminated, can your parent is waiting for the child to be terminated, or he is busy with some other work?
They're busy with other things. That
it's what? It's what they're saying. If a child gets terminated, and that time, if your parent is not waiting for the child to be terminated, then that process is terminated, but it is not removed from the process table. And that process basically come to a state called a zombie state. Yes. So what is saying? If a process does not, if a parent does not wait for the child when the child gets terminated, then the child process will go to a zombie state. So what is a zombie state? If you can write PS minus EL in this case, during this execution in another terminal, if you can find the PS minus ES, if this child will become 25, this is become 19, you can find in 25's state will be shown as a Z. Z means currently it is in the zombie state. So when it is removed, when the process finishes, when the parent finishes job and come out, that time it will be take this zombie process to be fully removed from the process table. So this is called as zombie state or zombie process. Now, what is the disadvantage of this zombie process? The zombie process is that if you are not handling the parent process to be wait for the child processes while the child process is terminated, in that scenario, the number of zombie processes inside the process table gets increased. As the number of zombie processes increase, every zombie process occupies one ID. Since our process ID is basically 16-bit, that is 2 to the power 16, means it is 65,000 something. If most of the processes is becoming zombie, then new processes cannot get a chance to be created because there is no process ID currently available for this one. So that's why it is called as a zombie process. And also in sometimes the operating system will not release all kind of resources from the processes. Because sometimes what happens, if a process gets dead, this process may get something from its parent processes. So if the parent process is not waiting and the child is dead, if the child is dead, the government cannot take the child's body. Rather, the government has to wait till your parent process has to come here, and then the child's body has to be taken for cremation also. That's the process. That's right.
Sir, but why is this happening? Because the parent is busy in some another thing.
Yes, I accept it. If the parent is busy with certain things, the parent has created a child. If a parent has created the child might have used some resources
Yes,
of the
sir.
parent. So if the child will be automatically dead, then those resources, if I remove, then parent cannot return back these resources while he is running it. Yes or no? Suppose my parents say एक चीज लाके मैं run कर रहा था. So if I'm going to die, obviously what will happen? With me, those resources also getting destroyed. If it is getting destroyed, my parent who is thinking about that resource is available with his son, it is not currently available because it is dead. That's why what they're saying, the child has to be worked inside the process table to release its resources. When it will release the resources? When the process, parent process, become active and waiting for the child to be terminated. But it has already terminated. Only thing, it is staying in the zombie state. Yes.
Sir, couldn't understand.
I could not understand. What I'm saying, if P1 is creating a P2 processes, P2 can it use some resources of P1 or not?
Yes, sir.
If it is using some resources, can this P2 will be destroyed without return back its resources?
No, sir.
Is it better or it has to be returned back? It has to be returned back.
Yes, sir.
If it will return back, if the zombie state will be not there, then it will be terminated, means its all resources are also terminated. Yes?
Yes, sir. Yes, sir.
But your parent is still waiting, knowing that my child has kept my resources. Definitely he will release it. He will give it to me. So he has to be give it to me. When the parent comes, tell that the child has your child has dead. Since the child has dead, whatever the resources or something he has kept, he has to be given. Then he will be properly removed from the process step. Yes,
Okay.
for that reason they have kept it. Understood?
Yes, sir.
Accepted? Okay, fine. So this is about the different kinds of processes. So what you have to do in the lab, if you have to do few things in the lab, you have to do a process creation. Yes. Another part you have to do, that is communication of the processes, which I have not told. I'll give a hint sometimes. Communication between two processes. Then you have to create a use the weight system call. Use weight system call, and you have to also create a process tree. Process tree means what? We have created a simple tree. This is a simple tree, but somebody may ask, can you create this process in this manner? Means P1 will be created P2, P3, P4. Then P3 will be created P5 and P6, and P6 will be created P7. Can you create these processes using your program? So this is called as the process tree. Okay, you can create this process tree and also test how the zombie process will be created. Yes, already I have written, only you have to test it in your own way. It is always when you are testing now, two things always open, one terminal, another terminal. In this terminal, always make a PS minus EL time to time, so that you can know whatever the process is created, it is showing it here or not. So based on this, you can see and do like this. And one more thing I told, but not very clearly told. I told that in case of your PCB, that is process control block, one scheduling information is there. scheduling info. So in this scheduling info, I told one important parameter used by our processes is called as the priority. Yes, and based on the priority, the process are running. Even if you go for the Windows, even if you go for this Linux, in most of the cases they are using the priority scheduling. Means based on certain priority, the process gets executed. So what happens here? Because of this priority, there is a fixed priority will be initially fixed, and later on you can change the priority. How you can change it? There is a command called as a nice, NIC. So please try to utilize this nice and verify yourself that since I am reducing the priority, it is delayed. If I'm increasing the priority, it is executing faster. So can you do these things by program and showing that, yes, sir, see, I have changed this priority, how fast it is. If I'm not changing the priority, how slow it is. So can you achieve this? So 5 things I told: process creation, communication. In this communication, you have to use a system called as pipe. I'll tell you now also. No, not an issue. I'll do a small communication within 2 processes. Yes, this is pipe, and this is a wait system call. Yes, there is also one function present in the Linux system called as a wait all, I think. Wait PID. Wait PID means for a particular child, he is waiting. Okay, you can just go through this wait. You can find many such functions. Try to utilize this. And this process tree is very interesting. I'll give a hint now also because it is necessary. And this one. So 1, 2, 3, 4, and 5. 5 cases. Yes, the process tree. I'll give a small example. Suppose I want to create this, and he has to be create this one. Yes, and we know how to create first part. How we are writing? For, tell me please, I equal to 0, I less than what? 2. Can you help? I less than 3, no? I less than 3, I plus plus. Correct? Because three processes you have created.
Yes.
Yes, 3 processes. And what you are writing? You are writing t equal to fork. When you are making t equal to fork, then after you are checking that if our t is what is the point? Can anybody tell me?
Sir, that odd number.
No. If t is equal to 0, basically you are writing break or not.
Yes, sir.
Yes, sir.
Yes, no. That is the possible cases you are making it. But now what you have to do? In this case, this t will be terminated. Very nice. But this particular t will be not terminated. When it will be terminated? Yes, when it will be terminated? Because for this now, this is when this t will be created, with which I value it is created? I equal to 0. This will be created with I equal to 1. This will be created with I equal to 2. So can you now tell me that when I equal to 1, that time 2 more processes is going to be created or not? Then what to do? Inside this, you can write a one more condition. If I is equal to 1, then inside you can create a for. Or I equal to 0, I is less than 2, or take a j. Better. J is less than 2 and a j plus plus. And here again you repeat this kind of code here. Okay, I've just given a hint for you. Yes, this is the way to create this child. Similarly, you can think of if any kind of child will be created, how you can do it. Yes, and I have also thought about one day before 5 years or 6 years, any tree you give me. Yes, can you write a recursive function? Any style tree you give me, any style. I'll prepare a format. You can create a tree just by a recursion. No need for doing anything like this. It is a simple tree. But if you think about that, it will be here also, here also, here also. Do you want to write if condition more? Bore ho jaoge. So how you design a tree without looking into which has how many childs and nothing. Just somebody will give a pattern. Based on the pattern, my recursive function will run and automatically it has to create. But the style I told how you have to do it, you have to do it by looking into what will be the I value. That is called as this. Yes, because these things again you have to cover in the lab. That's why I'm not going little deeper. One more point, that is process communication. Yes, the process communication. So what the process communication says that suppose there is a P1, I created P2, and this P1 wants to send one ABC to P2. If you can send ABC, obviously you can send many things. That is my requirement. So what you have to do it. So he's saying when you create a int main, look into it. Yes. So I have created this t equal to fork. And at this point, there are two processes created, that is P1 and that is P2. And I told you previously, there is no such link between these two processes. So if there is no link, I cannot keep this ABC somewhere so that my another process will take it. So what you have to do it? So they are saying, why don't you take the support of the OS? So what the OS says, the OS will be provide a bridge kind of things that is called as a pipe. There is a system called as pipe. So if you can able to create a pipe in between these two, every pipe has a two ends. One is a read end, one is a write end. So if this read end and the write end will be available to both these processes, then he can simply write and this will be read. Okay, what I'm saying, again I'm saying, you prepare a pipe, but who will give you the pipe? OS. What this pipe consists of? This pipe has two ends. One is a read end and one is a write end. And if this read end and the write end will be available to both these people, then you can simply say, sir, I'll write here, he will read it. What's wrong in that? Yes. So how to do this? How you can create a pipe? So before creating this fork, what I'll do, I'll create a pipe. There is a pipe system called. What it takes? It takes an integer array. Integer 2 size array. So I'll pass A. Yes. The moment I write down this pipe A, here at this point there is only one process was there. Since only one process was there, he has this A2. Yes, he has this A2 because I created this A2. Then I create a pipe. Means a pipe has created. A new pipe has nicely created. And this pipe's two ends now is stored in A0 and A1. Because one class I told, when you want to send some data to the printer or file or a monitor or everything, it looks like a file. If it looks like a file, we prepare a file descriptor. The file descriptor is nothing but a simple number, index. So that index will be stored in this A0 and A1. So let's take A0 will be stored with 5 and A1 will be stored with 9. Means through A0 is meant for the read purpose and A1 is meant for the write purpose. Then who has created? My P1 has created these things. The moment fork will be executed, what it does? The new process gets created. But while new process gets created, all the address space detail has to be copied. We studied. Means here also A2 gets copied. Means this process also knows about there is a 5, there is a 9. What is this 5 and 9? He's saying, think that it is a file. If it is become a file, there are two holes are present in this file. One hole meant for the read purpose, one hole meant for the write purpose. Since these are the holes, what is the hole here? The 9 is meant for this write and 5 is meant for this write. Who knows this? Both this process knows. If both this process knows what you want, P1 wants to send this ABC to him. So how will you do it? Who is P1 then? E power t greater than 0. He is this. What he wants to do? He wants to write. There is a write system call. Where to write? Sir, he wants to write to A1. What you want to write? ABC. How many characters? 3 characters. Done? Completed? Then what is the else part? Else part is my child. What the child wants to do? Whatever he has sent, no, he has to be received through this pipe. So how will he receive it? He will write it here, read. Yes. So from A0, comma. So how you can read it? Obviously, you have to give a kind of a character array. So you take a character array, so character T of suppose 10, and you tell that T comma this 10 means he is going to read maximum 10 characters from this buffer, and then you make a printf %s then T. Yes, so it will do it. So what will happen? Just I'll tell you, then you can ask me the question. What happens here now? Two processes here created. I told that this A2 has created prior to this creation of the child processes, and this A2 is nothing but keeping this two descriptor of the pipe, file descriptor of the pipe, and one is the read end, one is the write end. Why? How will not confuse? Please remember, आप हर टाइम read write बोलते हो या write read बोलते हो? जब भी हमको रीड राइट, कभी हम राइट रीड कभी बोल, इसलिए याद रखिएगा ऑलवेज 0 मीन्स फर्स्ट रीड, 1 मीन्स राइट. सिमिलरली हम जो पढ़े थे ना, एक होता है 0, एक होता है 1, एक होता है 2. सो 0 मीन्स रीड, मीन्स इट इज एसटीडी इन. दिस इज फॉर रीडिंग पर्पस, दिस इज फॉर राइटिंग. Okay, so what happens here? One problem here. What is the problem? The problem you can say, and every time you have to make a wait or these things you can write. After the creation of the fork, two processes are ready. Do you think that always this will be fast executed? May not. Just now we have studied, sir, which process will be executed first after the creation of the child? That is not in our hand. Even if the operating system also does not know. That moment, whatever the scheduler will be decided, that will happen. So if it is the scenario, then you can clearly tell either this will be executed or this will be executed. If it will be executed fast, but nothing has written to this buffer, to this pipe, then what? He is waiting. It is just like a scanf kind of statement or not? Yes or no? It is a kind of scanf statement. So he is waiting. Since nothing has written here, he waits. Then since it is waiting, obviously CPU to iske paas nahi jayega. The CPU will be switched. When the CPU will be switched to him, what is his work? Write this ABC. The moment ABC gets write by this P1 process to here, he will be read immediately and display it. Means the communication takes place. That example you can do what I have told here. Have you remembered this one? So what to do? You create one pipe here, one more pipe here, one pipe here, one more pipe here, one pipe here, one more pipe here. So what to do? When a number generated 5, through this 5 you send it. He will add some random number R1. Then through this pipe you send 5 plus R1. He will get 5 plus R1. Through this pipe again you add R2. And through this pipe you send it. He receive. Through another pipe he will send. Discard, send, discard. In this way. And similarly, as I have given 3 examples also, suppose you want to distribute it 2 into 3 plus of 2 division 3 plus of 2 minus 3, then how can you create a pipe? 2 pipes create कर लीजिए, एक pipe read के लिए, एक pipe write के लिए, एक pipe read के लिए, एक pipe write के लिए, एक pipe read के लिए, एक pipe write के लिए. So by this way what will happen? You send 2 into 3 to him. You send 2 by 3 into him. You send 2 minus 3 to him. How to send? Don't send 2 into 3 because it is a string. Don't send as a string. क्या करता है आपका programming? The programming इसको divide कर देता है 2 into 3. तो आप क्या करोगे? एक structure लिख लोगे. एक structure के अंदर 3 variable रख लोगे. क्या है? एक रहेगा int, एक रहेगा int, एक रहेगा char. The char will be make a star. Int will be keep the 2. Int will be these 3. So this is a structure. Since a structure, I can create a variable. If S1 is my structure variable, I want to send this structure variable directly through this. Okay. So in this way, that's okay. So this is the way. 4-5 things you have to do it in your lab. So next time, quick.
So जो पहले वाला अभी जो एग्जांपल दिए थे वो राइट ABC और फिर 3 था. सर लेकिन यहाँ पे वो रीड करे 10 साइज का, तो वो बफर ओवरफ्लो नहीं होगा?
नहीं, क्योंकि ये सोचिए कि ये तो जानता नहीं है ना कितना कैरेक्टर वो रीड करेगा. वो बोल रहा है कि मैं मैक्सिमम 10 कैरेक्टर रीड कर पाऊंगा. समझ पा रहे हो ना? बट कितना यहाँ पर है? 3 कैरेक्टर है. 3 रीड करने के बाद बंद हो जाएंगे.
ठीक है सर.
सो यूजुअली हम लोग क्या करते हैं कि जब भी कम्युनिकेशन करते हैं, जो सेंड करता है, यू कैन नॉट से दैट द वे द सेंडर इज सेंडिंग, the receiver may not receive in the same manner. Suppose I am capable to send 100 characters at a time, but you are capable to receive 20 characters at a time. Then what to do? If I am sending 100 and you are receiving by 20 size array, then how many times read you have to write? 5 times. And combine all 5 times data and think that this is my whole data. Okay? This is
Okay, sir.
so we'll go for the next important topic. So once you create a process, every process control block remembers a state, because without a state, a process has no meaning. So now we're going to study what is a process state transition diagram. Okay, so what is this? So first, we know we have to first create a process. कैसे create करते हैं? Dot slash I dot. पूरा कंसंट्रेट कीजिए. हाँ, कहीं पर भी मिस होगा तो आप मुझे बोलिएगा. फ्लो पूरा होना चाहिए, एक भी जगह पर मिस नहीं होना चाहिए. मैं क्रिएट किया a dot out. When a dot out was present initially where? Tell me quick. आपको पार्टिसिपेशन चाहिए, नहीं तो मजा नहीं आएगा. नहीं तो बुक में भी लिखा गया है. A dot out is present in the secondary memory. Very nice. When the process gets created, it will come to a state called as a new state. Can you give this guarantee that when a process immediately created, the memory will be available? May not be.
No, sir.
May not be. So that's why in the new state, still it is in the secondary memory. Means just now the process has created. Means you can say when you write a fork, the fork system called just create this process, but it does not have any memory. Or you may have a memory. If you have a memory, then what to do? This process is going to be executed. But when it is executed, executed by whom? Executed by the CPU. But do you think that when a process is created, memory is available, the CPU may be free, may not be free? That's what to do. He's saying when a process gets created, it is admitted to a state called as a ready state. By what? If the memory is available. Memory is available. समझ पाए? ये बोला? अगर memory नहीं है, then where it is currently, you can say still I am in some secondary memory. That is called as a ready suspended state. Yes, कहां पे आ जाएगा? अगर memory नहीं है, then it will come to this place. No memory. Or you can think no resources happen. So forget about this part now. Now you are coming, suppose the memory gets available, but when the memory gets available, you cannot say that immediately I am going to be executed. That's why he is kept in a state called as a ready state. Yes, what is this ready state meaning? The ready state meaning is that the processes are waiting here, are waiting to be executed. Means they have all the resources except the CPU. So क्या समझ रहे हो? Those processes are currently in the ready queue. Means they have all resources. Execution के लिए जो सब चाहिए सब कुछ उनके पास अभी है. But they don't have the CPU. Why? Because CPU is executing some other process. Since it is executed, suppose now the CPU has completed or partially completed the current process's execution. Then the CPU gets free. If the CPU gets free, then where the process has to go? The process has to be transferred to the CPU for the running state. Yes. So this you are saying it is a dispatched. And this basically in the bookish language, you can say that it is admitted. Okay. And this is dispatch. It is going to running state. Now tell me, is there only one process present in the ready state or there may be many?
Many.
Many. There will be one ready queue or there will be many ready queue.
The many ready queue.
Very nice. Many ready queue. Is it a many ready queue or it is better to only one ready queue? This ready queue is belongs to the system or this ready queue is belongs to individual processes?
The system.
System. If it is belongs to a system, means only one is present. If only one is present, means there is a queue called as the ready queue, and in the ready queue there are many processes currently present, and from this, out of these processes, one of the processes going for this running state. Then who is that? And who has to decide? The decision of the which process is going to the running state, that is done by a scheduler. So what is a scheduler? The scheduler is a simple program which takes a decision that which process is going to be selected from the ready queue to be executed by the CPU. Okay? एंड तक सबको पता चला. So process आ गया, memory इसको मिल गया. Once the memory is coming available, then it stays in this ready queue. So whenever the CPU gets free, one of the processes from this ready queue, depending upon some scheduling, like I told, if the processes are scheduled through priority, then whichever has the high priority, that process will be selected into this. So there are two things involved here. One is the scheduler, one is called as the dispatcher. The dispatcher's job is to take it and give it to him. The scheduler's job is to decide that which job has to be sent it to the CPU. Okay. Once you come to this running state, what are the possible cases? Suppose my program is currently running. What are the possible cases? Very simple case. Sir, umar gaya, terminated. Yes or no? This is called as terminated.
Sir,
You can
scheduler decides which process to execute.
again, please, again.
Sir, how the scheduler decides which process to be executed?
That there are different scheduling algorithm. After one class we are going to study. There is a round robin, FCS, shortest job, multi-level queue, multi-level feedback queue, all different types of them. Different operating system follows different scheduling algorithm. Based on this, it will be. Okay. Yes. But one question you have not asked, I will ask after 2 minutes. Wait. So it is gone. This is one case. Any other case?
IO.
Oh, very nice. Very nice. So when it is running, suppose one scanf is coming. So if the scanf is coming, what? One IO requirement comes. If the IO requirement comes, it will come to a state called as the blocked or waiting state. Yes, it is coming. So when the IO is coming, after the IO scanf gets over, where he has to go?
The ready state.
Very nice. Suppose मैं ऐसे लिखा हूं कि A equal to B plus C, A रन हो रहा था, उसके बाद तुरंत आ गया एक scanf. सोचिए ऐसा. Then where did it go? It will come here. Do you think that after the scanf gets over, it has to be here only terminated, or it has to be go for the next job?
It will go for the next job.
Means where to go? Here. Yes, means IO completion. समझ में आया? समझ में आ रहा है कि नहीं? Yes, this is one scenario. Can anybody think any other scenario by which
Error.
No, error को थोड़ा बाद में देखेंगे. वो तो पूरा गंदा चीज है. अभी बोलिए कि it is running and is there any other scenario? एक मरा, एक IO, और कुछ हो सकता है? एक धक्का देके बाहर निकाल दे. कौन सा वो है? धक्का देके बाहर निकालेंगे.
Sick kill.
Huh? Which case? Anybody? We have studied.
Kill.
What? Not able to hear.
Kill. Sick kill.
No, sick kill. धक्का देके बाहर निकालेंगे. एक पर्टिकुलर टाइप का ऑपरेटिंग सिस्टम पढ़े हैं. धक्का देके बाहर निकालेंगे कुछ देर बाद. Please don't think I am telling you.
Yes, sir. Yes, sir.
That is
punch card वाला.
टाइम सेविंग 2 मिनट्स खत्म हो गया तो कहां जाएगा? Suppose I have given you 2 minutes. CPU has a quantum time is 2.
Oh,
Once the 2 minutes gets completed, where you have to come? You have to
ready
come
to
from this or not. वहाँ पर धक्का देके आपको
take
बाहर.
the next process.
This is called as a timeout. Yes. Or there is one more case. Any other case? One case बोला exit मर गया. One case बोला IO requirement. एक केस बोला कि धक्का देके बाहर निकालेंगे.
Sir,
और
completed before time.
completed before time तो मर जाएगा.
हाँ.
वो तो मर गया. और कुछ हो सकता है? एक चीज बोल रहा हूँ. Suppose your process is running. During the process running, can on the top of the your desktop, the clock which is displaying that is changing or वो पूरा बंद हो जाता है आपका प्रोसेस रन होने के बाद वो चलता है.
चलता है background में. Able to notice.
बैकग्राउंड तो मिल जाइए, बैकग्राउंड मिल जाइए. आपका प्रोसेस जब VLC प्लेयर सपोज यहाँ पर रन हो रहा है, ड्यूरिंग दिस VLC प्लेयर रनिंग, डू यू थिंक दैट योर स्क्रीन में जो टॉप में
Sir,
जो
contact switching.
हाँ, ये जो नहीं 7.3, 7.4, 7.6 वो धीरे धीरे अपडेट होता है या
Yes,
कुछ
sir.
देर बाद एक साथ 7.10 आ जाता है.
अपडेट होता है.
से अपडेट होते रहते कंटिन्यू.
Yes,
सर,
मतलब
वो प्रायोरिटी जाता है.
हाँ, आफ्टर ईच क्लॉक टिक दैट मस्ट बी अपडेटेड. नहीं तो आपको लगेगा कि हमारा घंटा सही नहीं चल रहा है. मींस व्हाट? व्हेन माय प्रोग्राम इज रनिंग, some interrupt must be generated. Which interrupt? Timer interrupt. What is the work of this timer interrupt? It will change or update the system clock. Because अगर system clock update नहीं होगा, ये बहुत फायदेमंद होगा. क्यों बोलिए तो? If your clock not gets updated and if your quantum time is 2, कभी भी 2 नहीं होगा. हर टाइम 0 ही रहेगा आपका quantum time. Means after every second or millisecond you can see one interrupt gets generated. And what is that interrupt? That is the timer interrupt. And because of this timer interrupt, this process which is currently executing, that has to be come out. And what will be executed? क्या execute होगा? Timer interrupt के लिए सीखे हैं. जब भी interrupt call होता है, which program will get executed?
The interrupt service routine.
Very nice. Means one ISR program gets executed here, and somebody has already told because this ISR has a high priority. That's why it will be executed, and the process which is currently present here that will come out. Means because of timeout or because of interrupt, this process gets executed. समझ में आया? ये जनरल चीज सीखे. अभी थोड़ा सा हो जाता हूँ. Suppose a process is running and he wants to come out. है ना? उसको come out अभी करना है. When it has to come out from this, he wants to come here to the ready queue. Suppose उसको IO नहीं चाहिए. उसको चाहिए था कि मैं because of time out or because of interrupt I'll come out. But when it is come out, he needs a memory. Without a memory, can your process will be stay in the ready queue? नहीं रह पाएगा. Then where you will go? Can anybody tell me? What I'm saying? It has to be directly come to, very nicely as pointed out, it will be directly come to this particular state. Yes, where if the memory is not available, because it is my secondary state. Yes, and again, when the processes are present in the ready suspended state, is there any possibility to go to the ready state or not?
Sir, when memory is available, they can.
Yes, means they can go to this. Yes, that is बोलते हैं हम लोग resume कर लेते हैं. Yes, it is now resuming this. Now you tell me, if a process is present in the ready queue, is there any possibility that from the ready queue it will come to the ready suspended? ऐसे कोई हो सकता है? Ready queue से ready suspended आ सकता है? कब बोलिए? कब बोलना चाहिए?
सर हाई प्रायोरिटी कोई प्रोसेस आ गया तो
ठीक है, यहाँ नहीं रहा. बोलिए. हाँ, आप बोल चुके हो, 75% बोल चुके हो. क्या होगा? He is telling, if a high priority process comes, but currently I don't have a memory, then what to do? The existing processes, those who are present in the ready queue, that has to be come out. So this is suspended. Yes, हो गया? सीख गया? So there is a possibility to suspend from here, again resume here, and there is a possibility to directly bring the processes from the running state to the ready suspended state. Another interesting. एक ब्लॉक वेटिंग है. ब्लॉक वेटिंग में क्या करता है प्रोसेस? बोलिए. What you are doing? The block waiting step. Connect kind of things. IO काम करता है. ठीक है ना? Is this process is currently present in the memory? Yes. In the block waiting state also, it is still present in the memory. Suppose सोचिए कि आप लैब में बैठे हो, आप प्रोग्राम चला लिए, and स्कैनर पर अभी मांग रहा है, means the process has your process has come to the ready waiting state. And उस टाइम पे कोई एक बाहर से आपको बुलाया, आओ थोड़ा बाहर खा बिस्कुट खा के आते हैं, आप चले गए. Do we think that your operating system keep this process still in the block waiting state? बोलेगा कि बहुत देर तक वो ब्लिंक कर रहा है, वो कुछ नहीं कर रहा है. Then what to put? It is better to bring it to another outside fellow. That is called as block suspended state. Yes. फिर ऐसे सोचते जब वो बिस्कुट खा के आ गया, फिर बोलेगा कुछ क्लिक वगैरह कर देगा. Then he will go to this. So there may be a chances of a suspend, and there may be a chances of resume. ऐसे भी हो सकता है सर एक काम करने के बाद ना उसको लिए भी मेमोरी यहाँ पर नहीं था. And what to do? But he wants to go to this ready state. But ready state अभी खाली नहीं है. कहाँ जाएगा बोलिए तो? Suppose he has finished his work. He has finished his work. Neither he has here memory, and he does not want to stay here. क्योंकि वो बोला कि यहाँ पर जो लोग हैं उनका काम खत्म नहीं हुआ इसलिए यहाँ पर है. But my IO work is over. Why you are keeping me? Then where to go?
Suspended.
Yes. So it is called as IO over. IO is over, but no memory. Yes. So this whole thing is your process state transition diagram.
Excuse me, sir.
पूछिए.
So when we are going from running state to ready suspended state, then sir, what is the process called?
What is the process called means? What is the process? The process is
So like it for other you have written like resume or suspended. So
you can just say that it is because of some interrupt it has come out. Because of this interrupt and timeout, he comes out. Whatever you are writing now, that is because of what? This is because of timeout and interrupt. This is also because of timeout and interrupt. But in one case, he is because of timeout and interrupt, he enter into the ready state because the memory was available. And because of this timeout and interrupt, he come out from the running state, but enter into the ready suspended state because of no memory gets available. So this case and this case, both the cases because of timeout and interrupt. Okay?
yes, sir.
Yes. So next class हम पढ़ेंगे कि who is actually taking him out. And another interesting question कल तक आप सोच के आइएगा. आप सोचिए सर ये तो एक रन कर रहा था. आप बोलिए this process is running. How you can decide that next process will be enter? Suppose एक P1 process अभी run कर रहा है. How you can take a decision that the P2 process will be next enter? कौन डिसाइड करता है? शेड्यूलर.
प्रोग्राम काउंटर.
नहीं शेड्यूलर ना. सपोज एक P1 प्रोसेस अभी रन कर रहा है. Then the next process will be come to the P2. P2 will be selected among these processes which are currently present in the ready state. Then who is selecting this P2 among all these processes? I told scheduler. But the scheduler is a scheduling algorithm. Algorithm itself is a program. Means that program has to be executed. Then only the P2 select होगा ना. But my P1 is currently executing. How another program immediately enter? ऐसे कभी हो सकता है? Are you getting my point? P1 is currently executing by the CPU. Next process selection has to be done by a scheduler. But the scheduler is also a program. आप क्या बोलोगे मेरा प्रोग्राम डिसाइड कर देता है कि शेड्यूलर को आप आ जाइए? कभी नहीं. कौन शेड्यूलर को यहां खींचेगा? बिकॉज इट इज कॉन्टेक्स्ट स्विचिंग. तो दोनों प्रोसेस वो एक टेक्निक है. लेकिन कौन खींचेगा?
Sir-
who will call this scheduler program?
सर ओएस ही बुलाएगा।
OS, but OS is a program, no? वो program भी तो यहाँ आना चाहिए। वही तो मैं पूछ रहा हूँ। OS itself is a program. The scheduler belongs to the OS. If you can think that OS decide करेगा, मैं OS को अभी scheduler decide करेगा बोल रहा हूँ। But how the scheduler come to the CPU?
सर वो टाइम आउट सर्विस रूटीन का टाइम है शायद।
मतलब आप बोलोगे कि जब भी एक इंटरप्ट रन होता है inside your ISR program, there must be a last call will be a scheduler call. होगा कि नहीं? Because once your timer war gets over, means आपका स्क्रीन का टॉप में अपडेट हो गया, तुरंत क्या करेगा? ए स्केड्यूलर को बुलाएगा। क्यों स्केड्यूलर को बुलाएगा? Because of this timer interrupt, your P1 has already come out, and who is currently present? ISR. If ISR is currently running, who will decide that next who will come? Scheduler. Then this ISR's responsibility is to bring the scheduler. वो एक बोलोगे, मैं चेंज कर। हाँ
सर अगर क्वांटम टाइम अगर 2 है तो अप्रोक्सीमेटली 1.9 प्रोसेस को दिया गया है और वो 0.1 इन दोनों के लिए दिया जाएगा, वो इंटरप्ट और
नहीं, ऐसा कुछ जरूरी नहीं है। आप अगर 2 है, 2 यूनिट खत्म होने के बाद एक इंटरप्ट, अब टाइमर इंटरप्ट जनरेट होगा कि नहीं? होगा, वो डिसाइड कर दे।
ठीक है
ओके, दैट इज ओके। सो नेक्स्ट क्लास ज्यादा पढ़ेंगे, फिर इतना में बंद कर।
सर।
हाँ,
लेकिन वो टाइम आउट इंटरप्ट भी किसी को भेजना होगा ना?
टाइम आउट इंटरप्ट क्या? ओ टाइम आउट इंटरप्ट किसको भेजे? हाँ वो है। वो क्या होता है कि दिस इज लिटिल हार्डवेयर पार्ट। व्हेन इंटरप्ट ऑकर, आप बोलोगे सर इंटरप्ट तो ऑकर हुआ, फिर सीपीयू कैसे बंद हो गया? दैट इज हार्डवेयर। सो व्हेन इंटरप्ट इज कमिंग, some signal has to be come which will be stop the CPU space. नहीं तो कभी नहीं हो पाएगा ना। वो बहुत अच्छे क्वेश्चन पूछे, क्योंकि जब भी इंटरप्ट होगा, इंटरप्ट भी अगर सॉफ्टवेयर हो गया, देन उसको भी कौन कॉल करेगा? कोई नहीं ना। तो वो कभी भी सॉफ्टवेयर नहीं होगा डायरेक्ट।
सर वो क्या वो क्लॉक है, वो क्लॉक साइकिल?
वो क्लॉक साइकिल में देखिएगा कि एक एक टिक के लिए एक INT है उसका, INT 0x93, ऐसे डिफरेंट टाइप्स ऑफ इंटरप्ट है। वो एक सिग्नल जनरेट करता है सीपीयू को। सो बेस्ड ऑन दिस सिग्नल इट हैज टू बी।
ओके सर,
ओके, ठीक है। फिर टुडे दिस मच, आई विल क्लोज नाउ। Yes, whatever I told you, please do it, huh? Before going to the lab also you can practice, so that lab में आप जल्दी भी कर पाओगे।
Yes, sir.
Okay.